The other half of this section is the logarithmic family, or logarithmic parent function of the transcendental family, and basically it's the inverse of exponential. So we're going to look, it's called log of x. Specifically, we're going to look at log base 2 of x, because that's what the inverse of the 2 to the x that we use with the exponential. So if they're inverses, that means x and y have just flipped. So there's what the x's were for exponential. They're now the y's, and the y's become the x's. Very straightforward there. When we take our graph, that's what it'll end up looking like. So kind of what you would expect is that you have everything going to be flip-flopped. The domain of the exponential is now the range, and the range is not a domain. So the range is going to go up and down forever. The domain, you're never going to get into a negative value. So that's actually one of the big special properties, is that you're never going to have a negative number. Can't happen. Okay? X-intercept, Y-intercept, they flip-flop. Your X-intercept is 1, 0. The Y-intercept is the one that doesn't exist. And now, instead of having a horizontal asymptote, we should have a vertical asymptote. The vertical asymptote is this vertical line of y equals 0, because we're never going to reach into the negative value. So remember, the e to the x started flat and then got really quickly going up. The ln of x is complete opposite. It starts going really strong and then tails off. So if you want to think of it, well, because we can right now with the COVID outbreak, it starts really small and then gets really, really big. Well, over time, you're going to run out of people that COVID can infect. So that means that it's going to, after going up really quickly, has to eventually start tapering off because there's no more that can be infected. But if you remember, really important, the way that you can tell functions are inverses is if you drew this line right here and you flip the graphs over that line, reflected, folded over that line, you should get the exact same graph. And there you go. There you do. Now, the blue line is the logarithmic. It's neither an even or odd function, but it is one-to-one. Transcendental, log, and exponential will be. Your special point is that starting point that we just talked about. It's that 1, 0. That's really big. And some special properties as I reveal them over here. First one, we can say log of x without putting a base there, without putting a number. It is assumed if there is no base that we're in base 10, because that's what we count with. We have 10 fingers. That's the numbers that we're going to have. Okay? The other one, log base e. Remember we said e is very important, the 2.71. It is so special that it gets its own function, ln, the natural log. Log natural was the, I believe that was a Latin expression, ln of x. And we kind of said it there. You can't take log of a negative number. Here's how you need to look at this, though. The way you would read this to put it outwards. Log base 2 of negative 8, you would read that as 2 to the third power equals negative 8. Well, that definitely isn't the case. That would be the case right there. 2 to the third power equals 8. Base to the answer is the exponent. So you can't have that negative on the inside. It would never happen. You can never raise to an exponent and get a negative number. We'll talk more about that with the algebra as we go along here in a minute. So the way we will graph these ones, log of x means you put your starting point at 0, 1, or I'm sorry, 1, 0. You draw your vertical asymptote, and you start by going up really quickly, and then when you hit your point, you flatten yourself out, and there you go. Whether that's log base x, log base 2 of x, log base 20 of x, doesn't matter. That's going to be the most that we go into graphing these. This one here, you have your generic outside and inside. So moving your starting point, which was at 1, 0, moving it to the right 2 and up 3, puts it right there. You move that vertical asymptote to the right 2 as well. And same thing, you start by going up strong, you hit that starting point, and go flat. All I'm really looking for in these graphs is the starting point, the asymptote, and that you flatten out. Whether you have log, ln, log base 4, we're going to treat them all the same in the way that they look. Moving is moving down 7 in this guy. There's nothing on the inside, so your asymptote here stays the same. And technically, this guy should go up a little bit quicker than the other one, so maybe it doesn't flatten out quite as quickly, but it should definitely still do so. So something maybe like that. This one moves to the left 4. 1, 2, 3, 4. Make sure you move the point and the asymptote. And the negative means that you're going to have a vertical flip. So in quick